Okay, question 11. Now, magnesium react with my dilute sulfuric acid to form magnesium sulfate and hydrogen. In this case, 2.4 grams of magnesium reacts exactly with 100 cm³ or 1 mole per dm³ of sulfuric acid to give 2.4 dm³ of hydrogen at room temperature and pressure. Okay, which rule will give 4.8 dm³ of hydrogen at room temperature and pressure? First of all, let's calculate the number of moles of magnesium that was being used. Okay, number of moles of Mg. In this case, we know that we take the mass divided by the total Ar, which is 24 that is found on the periodic table. In this case, they give you a 0.1 mole. Next, let's calculate the number of mole of sulfuric acid that was used to react. H2SO4. Okay, we will take my 1 mole per dm³ times 100 over 1000. This should give you a 0.1 mole. Okay, in this case, we will know that the number of mole of magnesium to the number of mole of sulfuric acid is, in this case, is 0.1 as well. Due to the coefficient, okay, so what we write is, according to the equation, we know that the coefficient of magnesium is 1, the coefficient of H2SO4 is 1, and the coefficient of H2 is 1 as well. So, the amount of H2 produced should be 0.1 mole as well. Okay, so according to the equation, 1 mole of Mg produces 1 mole of H2. In this case, none of them were in limiting, none of them were in excess. So it's exactly 1:1. So therefore, to say that 0.1 mole of Mg produces 0.1 mole of H2. Alright, this is what was given. Hence, the volume of H2 that was being produced should be my 0.1 times 24, which is equal to 2.4 cm³. In this case, if we want to produce 4.8 dm³ of H2, okay, what will happen is, in this case, we will need 0.2 mole of the limiting reactant. Okay, in this case, at first, right, when we are using 2.4 grams of magnesium and 0.1 mole of my sulfuric acid, none of them were in excess or limiting. However, again, if you want double of what was found, okay, you will need double of the limiting reagent because we always trust the limiting reagent. So in this case, option A is and option B is definitely out. And in this case, the concentration here should be also double in order to find that the hydrogen produced will be at 4.8 moles. Okay, let's take a look at whether is it true. Okay, if 4.8 grams of magnesium was being used, so in this case, number of mole of Mg should be the mass again divided by the mR. In this case, will give you a 0.2 mole. Number of mole of H2SO4. In this case, same thing, we will take 2 times 100 over 1000. In this case, again, 0.2 moles. Okay, since again the ratio is 1:1:1, the amount of mole of H2 will also be 0.2 because the coefficient is now all the same. And when 0.2 moles of H2 was being produced, what will happen is the volume of H2 that was being produced will be 0.2 times 24, which will give you a 4.8 dm³. Sorry, the previous part should be in dm³. Alright, so in this case, we need double of the limiting reagent in order to get double of the previous result. So in this case, answer here should be D.